Part two, here we go. So on this one, slide 13. This means that you have this packet and you are right here on part two. That means you had to have completed name, core, all these definitions up here. Do you feel you need this question here? All these percentages right here, this question right there, and then questions 2, 3, 4. Done all this. 5, 6, 7. All right. Um, yeah, sorry. And then for part two, it's right here. So for part two, let's take a look. We're going to need this sim. We're going to open that up. Looks like this. And then you hit the start button. Yep, wait for it to load. We're going to start off with waves. So select the greenhouse effect link and then choose waves. Hey, we chose it correctly. And then click start sunlight. Oh, we didn't start that yet. So start sunlight right there. Okay, yeah, now we're on to it. All right. There are two types of energy in the simulation. Is the sunlight infrared or visible? So sunlight's right here, and between infrared, which is down here, and then the other option, I'm pretty sure it's the other option. It starts with the V. Oh yeah, and it's right there. All right, awesome. Which type of radiation has a shorter wavelength? Waves closer together and a higher energy level. So damn, yo, let me take a look at this. Wavelengths closer together. Oh yeah. The peaks are kind of right there. They're kind of closer together. Yep, so that answers that one. All right. Change the temp to Fahrenheit. What's the temp? So I got change this right here to Fahrenheit. 30. Yeah, man. It's like that's the temperature right there now in Fahrenheit. Throw that baby right there. Right. Awesome. Which type of energy are absorbed by the Earth's surface? Okay, so it looks like what's coming down and gets absorbed, it's the yellow energy, which is the or that starts with a V. All right. Now, let's see what the next question is. Which type of energy is radiated by the Earth's surface? So if I'm looking at this, oh, wait a minute. Radiated means gives off. It's the red one. Awesome. Um, what happens to the sunlight as it hits the cloud? Unclick the cloud button and compare what happens to the temperature compared to your answer for number 3. All right, so sunlight hits the cloud. Dang, some of it gets reflected back up. Okay. Yeah, that's definitely. All right, now let's get rid of that cloud. See what happens. So we're at 39.7. Oh, dang. Yo, it's getting hotter. Mm. Yeah, it's getting warm. So, all right. So reflected. All right, and down here gets hotter. Click on the energy balance. Oh, click on the energy balance. Oh, sweet energy balance. All right, input, output. Awesome. Move the slider for greenhouse gas concentration to lots and then none. Describe what happens. Ooh, okay. Let's see if we got this. That's this thing. So if we move it lots, it looks like it gets hazier, by the way. And what happens to the temperature? Dang, damn, still going up. All right, now let's drop it to none. Ooh, it gets like a lot clearer. Like it's more blue. It's like not as hazy. Oh, but wait a minute. Look at that temperature. Oh, dang. Right there. If we were in Ireland, they'd be saying it'd be cold as a witch's heart. So, all right. Yep, I think that basically tells you what happens there. All right. Click on the calendar looking button next to the slider button. it should show 2020, 1950, 1750, and Ice Age. When you click on these four buttons, what happens? All right, so let's take a look. Here's the calendar button here. All right, so 2020. Oh, all right. So if I'm looking here, we have wind turbines. We've got factories producing carbon dioxide, probably some methane as well. We got clouds, and the temperature is 58.3. We got input and output. All right. Now, let's go to 1950. All right, we have no wind turbine. We still have a factory. Although there's only one smokestack, I think. Let's see. That one's got two. Oh yeah, we got more. Yeah, yeah. So we're using more energy, I guess. And the temperature is going down in 1950. Let's see what we got. 1750. Yo, dang, we got rid of all the factories and the houses. We just got a barn and some sheep. Temperature went down too. All right. Yeah, let's go for it. Let's do Ice Age. Ooh, all right. Man, forget your sheep. Forget the barn too. Too dang cold for that. Temperature's still going down. So, interesting enough, it's the sunlight's reflecting off the cloud, but it's also reflecting off the ice. Cool. It didn't reflect really off the green fields. All right. So, for down here, start telling me the difference between what you saw, the difference between 2020, 1950, 1750, and the Ice Age. You could talk about the buildings. You could talk about how which one was looked hazier, which one looked clearer, which what happened to the temperature. So now at the bottom, we change it from waves to photon, then click the calendar looking button again. So, yep, we're going to change it down here. It's hard to see this, but if you can see it, it's the one right here in the middle. Yeah, we're going to hit start sunlight, waves to photon, right? Now here's the calendar looking app. All right, so we did that according to the directions. Um, the bottom waves to photons, then click the calendar looking button again. Click on the Ice Age button and record. So, yep, we're going to click Ice Age right here. Oh, okay. So we got these numbers down here for CO2, CH4, N2O. Oh, yeah, and we got the temperature. Okay. Yep. So I would record these numbers right here, and then I would record this number right here. I might change that to Fahrenheit. That's a little more. All right. Click on the 1750 button and record. Oh, okay. So now we're going to click 1750. All right. Record these numbers here and record the temperature once it stops. If it stops, yeah, still going high. Yeah, there we go. All right. Now, um, click the 1950 button, record, and then click the 2020 button, record. I'll just go through that. So, yep, you're going to hit 1950. Boom. As you hit 1950, record the carbon dioxide, record the methane, record the nitrogen. That's nitrogen dioxide. All right, N2O. Sorry, guys, I'm drawing a blame blank. And then right here, record temperature. Now we get to 2020. Interesting enough, this is a COVID year. And during COVID year, the greenhouse gases went down compared to where they were thinking about where they would be. Um, so right here, those are the numbers you're looking at, and look at the temperature right through there. Yep. So awesome. All right, so we did these right there. What happens to sunlight photons as they hit the ground? Let's take a look here. So let's see yellow. Let's see. It's going to hit the ground. Okay, gets absorbed. That's what happens. Yeah, they're all getting absorbed. All right, awesome. Um, yeah, put it back on Ice Age. Oh, okay. Ice Age. Oh, wait a minute. Yeah, just like that. Now, sunlight comes down. That one gets, oh, wait, that one gets rebounded. That one gets rebounded. That one gets rebounded. Dang, yo, that one gets rebounded. That one gets rebounded. That one gets rebounded. So as it hits, the sunlight hits the ice, it gets rebounded. Um, what happens to sunlight photons? They hit strike the ice. Okay. Now number 4, what happens to sunlight photon hits a cloud? Ooh, okay. Let's take a look at that one too. We got a cloud right here. All right. So the first one went through. Oh, wait a minute. That one got rebounded. All right. Yes. Got rebounded. Not as much though as the ice, but yeah, some of them get rebounded. What effect do clouds and ice have on the temperature? Ooh, well, here's a hint for you. What's the age? I think you can figure out the temperature. Um, how has the concentration of greenhouse gases changed from the ice ages to the 1750s? How has the average temperature risen as a result of these additional greenhouse gases? Yeah, so look here. Looks what has the greenhouse gases from the ice age down to today, have they increased or decreased? And has the temperature increased or decreased? Yep, that would be a good one to look up for right here. Now, part 3. Yep, I think we'll do that in a separate video.